Struggle with differentiating a function again if you watch this video by chain rule. To differentiate a function using chain rule, we use chain rule to differentiate functions that are complicated. For instance, if you are told to differentiate a function y is equal to something like 5x squared plus 4, then raised to power 6. You can see that it's very difficult to expand this function in the box up to what? Power 6. That's multiplying the function to itself up to 6 times. That will take a lot of time and a lot of spaces. So using this chain rule, it helps us to arrive at the solution faster and more efficient. But before we use this chain rule, you should recall the general form of differentiating a function. That whenever, in general form, whenever you are given y to be equal to x power n, if you are differentiating, all you have to do, that's the dy dx, is now equal to what? You multiply the power, this is the power, to the variable and minus 1 from the power. That will give you nx n minus 1. This is the general form of differentiation. So for us to differentiate this, we have now an inner term and we have the general function. So to differentiate this, we first of all differentiate the whole function. After that, we'll multiply it by the derivative of the inner function. Let me show you what I mean. For us to do that using chain rule, dy dx, differentiating y with respect to x under chain rule, suggests that you have to differentiate the inner function. So the inner function, I can now call it u. Okay? The inner function is now u. So 5x squared plus 4 is the inner function. So I'll call it u. So to do that, I have to differentiate y with respect to the inner function u. Then I multiply it to, when I differentiate the inner function u in terms of the variable x. Okay? So this is the general formula to differentiate a function using chain rule. This is the formula. So all we have to ask ourselves is, how can we differentiate all these things? By using this formula, you now see that y is now equal to the inner function we called u raised to power 6. So differentiating y with respect to u implies differentiating this term inside the bracket. And that will give you what? 6 u to the power of, we are differentiating this now, to the power of 6 minus 1. And that will give you what? 6u to the power of 5. The next thing we have to do is just to differentiate the next function. That's differentiating u with respect to x. Remember, our u is the item inside the bracket. So we now say that differentiating u with respect to x is equal to, we'll multiply the power 5 to the constant 2 times 5, then minus 1 from the power. 2 minus 1 is 1. So 2 times 5 is 10. We have it as 10x. So remember, our goal is to find dy dx. So differentiating y with respect to x will now be equal to differentiating y with respect to u, which we got as 6u to the power of 5. Then we'll multiply it to differentiating u with respect to x, which is what? 10x. So if we simplify this, we have 6 times 10 is 60. We have it as 60x, then u to the power of 5. So at this point, you are going to substitute back the value for u. Our u is the item in the bracket, and that will be 60x into the term in the bracket, inner term, 5x squared plus 4, then raised to power what? Here we are using 5, the already differentiated function. And that's the required solution. Okay? Let's look at the next question on our list. We are given that y is equals to ln 3x power 7 plus 1 find the y dx. This is the second question on using chain rule to differentiate a function. So to remind you, remember that the chain rule is the y dx is equal to differentiating u with respect to x times differentiating y with respect to u. Okay? Then we assign our u to be the inner term. This is the inner term and this is the outer term. So you can now see that our u is 3x power 7 plus 1, the inner expressions. Then we can now see that y, which is the main function, will be equals to ln u. Okay? Then remember, our goal is to differentiate y with respect to x. So first thing first, look at the formula. We are expected to differentiate u with respect to x. After that, we differentiate y with respect to u and multiply both. So to do this, you can now see that one simple thing you notice is that differentiating y with respect to u is equal to, we are trying to differentiate ln u, and that will be what? 1 over u. Then again, the next thing we have to do is to differentiate u with respect to x. Remember when you are differentiating a function, but before then, like this video, share this video to your friends, also subscribe to my YouTube channel, click the bell icon so that you'll be notified whenever I drop a new one. Let's continue. And differentiating, this is the u now, with respect to x. We multiply the power to the what? Constant and minus 1 from the power. That's 7 times 3x to the power of 7 minus 1. Differentiating a constant 1 is 0, so no need of writing it. This will now give us what? 7 times 3 is 21. We have 21x to the power of 7 minus 1 is 6. So remember, the general form of the differentiation by chain rule, dy dx, is equal to differentiating u with respect to x, u with respect to x as well. Differentiating u with respect to x is 1 over u, then times differentiating u, is differentiating y with respect to u, which is 1 over u, and differentiating u with respect to x, which is 21x power 6. And this will give you 1 times 21x power 6 will give you 21x power 6 all over u. You have it as u. What then is the value for u? Because we are solving it back. 3x power 7 plus 1. We have it as 3x power 7 plus 1. And this is the complete differentiation of this function y with respect to x. Do well to like, comment, and share for more exciting math tutorials like this. See you next time.